The quest for a unified theory in physics, often called the theory of everything, or TOE, has been one of the most ambitious and challenging pursuits in modern science. For decades, physicists have been striving to reconcile the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, into a single, coherent framework that explains the universe at all scales. Today, we'll explore this fascinating quest, focusing on two leading contenders in the race for a unified theory: string theory and loop quantum gravity. Let's start with some background. Our current understanding of the universe is built on two pillars: general relativity, which describes gravity and the large-scale structure of the cosmos, and quantum mechanics, which governs the behaviour of matter and energy at the smallest scales. While both theories have been incredibly successful in their respective domains, they're incompatible when it comes to extreme conditions like the interiors of black holes or the first moments of the Big Bang. This is where the need for a theory of everything comes in. Such a theory would not only unify all fundamental forces, but also provide a consistent description of reality across all scales, from the quantum realm to the cosmic. Now, let's dive into string theory. Developed in the late 1960s and gaining prominence in the 1980s, string theory proposes that the fundamental constituents of the universe are not point-like particles, but tiny, vibrating strings of energy. These strings, vibrating in different ways, give rise to all the particles and forces we observe. One of the most striking features of string theory is its prediction of extra dimensions. While we perceive 4 dimensions, 3 of space and 1 of time, string theory suggests there might be 10, 11, or even 26 dimensions, most of which are curled up so small we can't detect them. String theory has been hailed for its elegance and potential to unify all forces of nature. However, it faces significant challenges, including the lack of experimental evidence and the difficulty in making testable predictions. On the other side of the theoretical divide, we have loop quantum gravity, LQG. Developed in the 1980s by physicists like Carlo Rovelli and Lee Smolin, LQG takes a different approach to unifying physics. Instead of focusing on the behaviour of objects within space-time, LQG attempts to quantize space-time itself. It proposes that space is not continuous, but made up of discrete atoms of space, connected in a complex network. This network, when viewed at large scales, gives the illusion of smooth, continuous space-time. Unlike string theory, LQG doesn't require extra dimensions. It works within the 4 dimensions we observe. However, it does suggest that at the smallest scales, the Planck scale, space-time has a granular structure. Now, let's compare these two approaches. Both string theory and LQG aim to reconcile general relativity with quantum mechanics, providing a unified description of all fundamental forces. They're both highly mathematical and theoretical, pushing the boundaries of our understanding of physics. However, they differ significantly in their approaches. String theory focuses on one-dimensional strings as the fundamental building blocks of the universe, while LQG concentrates on quantizing space-time itself. String theory requires extra dimensions and incorporates supersymmetry, a proposed symmetry between fermions and bosons. LQG, on the other hand, works within our observed 4 dimensions and doesn't rely on supersymmetry. Both theories face significant challenges when it comes to experimental verification. The energies required to test their predictions directly are far beyond our current technological capabilities. Despite these challenges, research in both fields continues to advance. String theorists are exploring connections between gravity and quantum information theory through concepts like the ADS-CFT correspondence. Meanwhile, LQG researchers are working on applying their techniques to cosmology and black hole physics. Recent developments have even suggested potential bridges between these seemingly disparate approaches. Some researchers argue that string theory and LQG might be different aspects of the same underlying theory, viewed from different perspectives. What does Quran say about this topic? The Quran mentions the existence of both the seen and unseen worlds, aligning with the idea of multiple realities in physics. As stated in the Quran, "And he is the knower of the unseen and the witnessed, the grand, the exalted." Quran 13:9. The Quran emphasizes that Allah created everything in pairs, which can be related to concepts in modern physics. "And of everything we have created pairs that you may remember." Quran 51:49. Glory to Allah, who created in pairs all things that the earth produces, as well as their own, humankind, and other things of which they have no knowledge. Quran 36:36. It is truly astonishing to see that the verse about pairs is also numbered as a pair. 36:36. This concept of pairs extends beyond just male and female, but includes opposites and counterparts in various aspects of creation, such as night and day, heaven and earth, sun and moon, land and sea, light and darkness, faith and disbelief, happiness and sorrow, paradise and hell. Islamic scholars interpret this concept of pairs as applying to both the physical and metaphysical realms, including emotions, characteristics, and even unseen realities we may not yet comprehend. The Quranic emphasis on pairs and the unseen can be related to modern scientific concepts like matter and antimatter in quantum physics, or the idea of multiple dimensions in string theory. The Quran encourages reflection on these pairs as a means to recognize the oneness and power of the Creator. That you may remember, Quran 51:49, is interpreted to mean that we should contemplate these pairs to understand that the Creator is one, with no partner or associate. We will discuss the significance of these numbers, 3, 6, 9, in another video. The hadith narrated by Ibn Abbas, may Allah be pleased with him, regarding Surah At-Talaq 65:12, can be intriguingly related to the theory of everything. The hadith states, Ibn Abbas, may Allah be pleased with him, commented on Surah At-Talaq, "It is Allah who has created 7 heavens and of the earth, the like thereof." He said, "In each heaven is a prophet like your prophet, Adam like Adam, Noah like Noah, Abraham like Abraham, Jesus like Jesus, and Moses like Moses." In Islamic cosmology, this suggests a layered, interconnected universe where each layer or heaven contains its own prophets and counterparts to the earthly figures we know. This multiplicity and interconnectedness bear a resemblance to the ambitions of the theory of everything in physics. Drawing a parallel, the hadith suggests a profound interconnectedness and symmetry across the different heavens and earths, where similar figures and elements exist in each. This mirrors the TOE's goal of finding a unified theory that underlies the diversity and complexity of the universe. Just as the TOE strives to show that all forces and particles are manifestations of a single underlying principle, the Hadith implies a deeper, divine symmetry and connection across different realms of existence. In conclusion, the quest for a theory of everything remains one of the most exciting frontiers in physics. While string theory and loop quantum gravity offer different paths towards this goal, both have contributed significantly to our understanding of fundamental physics. As we continue to push the boundaries of our knowledge, who knows what revelations await? The theory of everything, if discovered, could revolutionize our understanding of the universe, potentially leading to technological advancements we can barely imagine today. Whether through string theory, loop quantum gravity, or perhaps some yet-to-be-discovered approach, the pursuit of a unified theory continues to drive physics forward, reminding us of the profound mysteries that still lie at the heart of our universe. Stay curious, keep exploring, and who knows, maybe you'll be the one to unlock the secrets of the cosmos.